So introduction to electrical engineering and Ohm's law is finished. Kirchhoff's laws. What is the Kirchhoff's laws? KCL and KVL is finished. And the basic circuit components, voltage source, current source, resistor, and some definitions also finished. And simple problems, some simple problems we did on this one. So this is about some basics related to electrical engineering. And we already discussed about some basic definitions. What is the voltage, current, power, node, branch, all these definitions we discussed. Types of elements we have to discuss and the types of sources. So today we will discuss about types of elements and types of sources. Use this notebook. I will share this notebook for your reference also. See, PDF కనిపిస్తుందమ్మా? Everybody is able to see this PDF. Electrical circuit. Please respond yes or no. I shared the PDF.
Yes, sir. Kanipistundi.
Yeah, okay, thank you. What is an electrical circuit? We already discussed about the electrical circuit. What is an electrical circuit? It is an interconnection of electrical elements. What are those elements? Voltage source, current source, and resistive elements. In addition to this one, inductor and capacitor. So far we have discussed about voltage, current and resistor and power. We have to discuss about inductor and capacitor. Okay. And the current can only flow in the particular circuit for closed path. Whenever the closed path is available, then only current will flow. Closed path means circuit should be closed. Either by switch or some wire, the circuit should be closed. This electrical circuit consisting of following parts. One is the source must be there. Either it should be an voltage source or it should be an current source. Then only it can deliver the current. But circuit work kavalante, either there is an voltage source or current source like this, plus minus, a voltage source which deliver the current I like this, or current source. How to represent a current source? Circle inside a circle arrow. That arrow represents a current. Compulsory there must be a source. Then only it can deliver the energy. Okay, that is should be consisting of a source. Second one, that should be consisting of a load. Load will be there, and the load may be in electrical appliances. The load may be a fan or bulb or motors. These motors can be modeled as a resistive elements. So our supply board is modeled as plus minus, and this is inductive source, and this fan or bulb will be modeled as a source. This is voltage. It is a circuit, and to on and off there should be a switch, and other than the switch we have connecting wires which are used to connect the source and the particular load. These are the components in a electrical circuit. Suppose if you see a practical situation, this is a source, an example of battery which will deliver the current. And one more thing is that I already told, if there is a voltage source is like this, a 20 volt source is, say for example, it can deliver the current. Current is always delivered from the positive terminal. Current is entering at the negative and delivering from the positive. That is a thumb rule. Current is always start from positive terminal. Okay, that is a thumb rule. It can flow only there is a closed path. If there is no element is connected, current will not flow. So current requires a closed path. How can you close this path? By using a load, a resistive load. Resistor is an equivalent of a heater or equivalent of a fan. All those things can be modeled as a resistive elements. So in a particular electrical circuit, there must be a source, and there must be a load, there must be a switch, and there must be a wire connecting wires. We already talked about this electrical circuit. Just I am giving a brief view of this concept. Now, so you have seen source is one of the part of this circuit. Source, it may be voltage source or current source. Now let us see classification or types of the sources. Okay. So the most important elements or sources are active elements, and passive. Another classification is passive element. Active element and passive. So these active elements are the elements which are able to give the energy to the other elements. So what are the examples for the active elements here? Voltage source and current source, just now I have discussed. So these elements can deliver the power to the circuit which are connected in the particular circuit. Okay. So these elements, what are the voltage source, current source, voltage source, current source, and resistors? These are categorized into two. One is the active elements, another one is passive elements. Let us see about these active and passive elements so clearly. I will use the PDF here. See, these circuit elements, see here, the circuit elements are categorized into passive elements and active elements. Okay. Wait for 1 minute. Yeah. Please, am I audible to everyone? Anna? Please respond. Are you able to understand here? So these circuit elements are categorized into two types. One is active element, another one is passive element. Active elements are capable of generating the energy, or capable of delivering the energy. Energy means electrical energy only. The examples are batteries and generators. So batteries can give a DC source or DC supply, and generators are giving AC. The generators are available at generating stations like Nagarjuna Sagar, Ramagundam power plants, and batteries will give a DC. And we know the symbolic representation for the DC is plus and minus PV. For AC, this is about the voltage sources, and current sources will act as a current source is also known as the active elements. Auto represents a current source circle inside a arrow. The arrow indicates the direction of the current. Okay, na? So these are come under active elements which can give energy to the other elements in a particular circuit. Now, passive elements are not capable of generating energy. These elements can absorb the energy or dissipate the energy. Examples are resistors, capacitors, and inductors. Okay, so in a particular circuit, if you connect a resistive element, this current source can able to give electrical energy to this element. This element, resistive element, will be dissipate that energy in the form of heat. For example, if you take a heater, so that will take electrical energy and it will dissipate. That means it can convert electrical to heat energy. Those resistors can take only energy. Those resistors cannot generate or cannot give the energy. The type of elements, the elements which are available in circuits, which are taking the energy from the active elements, are known as a passive elements. Examples are resistor, capacitor, and inductors. Okay, and active elements are voltage sources and current sources. Now, let us take another classification. This is based on the elements. Now, if you take the sources, what are the sources? These are the elements which are trying to give the energy, and there are some types of the sources. Let us see the type of the sources one by one. Are you able to understand what do you mean by active elements and passive elements? Active elements are the voltage sources and current sources. Passive elements are the resistor, inductor, and capacitor. Active elements means these are capable of generating the electrical energy. They will deliver the energy to the resistive elements, capacitive elements, and inductive elements. For example, if I take a circuit like this, a voltage source, in this voltage source, resistor is there, inductor is there, and capacitors are there. In this circuit, this voltage source is trying to give some energy in the form of voltage. Okay, so this is known as a active element. Other element, resistor, capacitor, and inductor elements, are known as a passive elements. So this is about the classification of active elements and passive elements. Okay. Now, let us discuss about the sources, classification of the sources. Let me use the notes for this one. Sources. What do you mean by a source? Which can give the electrical energy. So types of the sources here. One is independent sources. I will tell what do you mean by independent source. One is independent source, another one is dependent source. This classification is important. Independent source, another one is dependent source. Next, again these independent sources are categorized into voltage source and current sources. Okay, now voltage source and current sources. Again, this voltage source is categorized into ideal voltage source and ideal practical voltage source. Ideal voltage source and practical voltage source. And again, this ideal voltage source is categorized, classified into DC source and AC source. This practical source also categorized into DC source and AC source. And in the current source also we have ideal current and practical current. And again in the ideal current we have AC current and DC current. And in the practical current also we have DC and AC. So likewise, these are come under independent sources. Independent sources means the value of this voltage source. Suppose this is a 20 volt source. This 20 volt source, it doesn't depend on any element which is present in the electrical circuit. Suppose a resistor is there. This value of this voltage doesn't depend on any element in the circuit. Suppose resistor R is there. This value of voltage doesn't depend upon this resistance. That is the independent source. Independent, it doesn't depend on. Next, dependent sources are classified into voltage controlled sources and current controlled sources. And again, these voltage controlled sources are classified into voltage controlled voltage source. VC, VS means voltage controlled voltage source. VC, CS means voltage controlled current source. And current controlled sources are categorized into current controlled voltage source, current controlled current source. So this is the classification. Don't confuse here. I will explain clearly one by one what is what. Yeah, let us see what is the independent source. Independent source is an element that provides a specified voltage or current that is completely independent of the other circuit elements. Example is battery and generator. The value of this voltage doesn't depend on other element which is present in the circuit. Got it? The value of that particular source doesn't depend. It is a fixed one. But if you take a dependent source voltage, and this is also an active element, but the source quantity is controlled by another voltage or current. For example, and these are represented with the diamond symbol. Diamond symbol. I will talk about this dependent source later. First, we will discuss about these independent sources, ideal and practical. Are you following? Please respond on it. Are you following?
Yes, sir, follow.
Good.
Yes.
Yeah, let me talk about this independent sources. And independent sources also categorized into two types. One is ideal voltage source. చాలా ఇంపార్టెంట్, జాగ్రత్తగా వినండి. ఐడియల్ పర్సన్స్ అంటారు కదా, ఐడియల్ వోల్టేజ్ సోర్స్. అన్ని క్యారెక్టర్స్ అని గుడ్ ఉంటాయి, అందుకని ఐడియల్ పర్సన్స్ అంటారు. అండ్ ప్రాక్టికల్ వోల్టేజ్ సోర్సెస్. లెట్ us see the difference. ఇవన్నీ మీకు అర్థమైతేనే నెక్స్ట్ ప్రాబ్లం చేసేటప్పుడు ఈజీగా ఉంటుంది. లెట్ us see one by one. What is the meaning of ideal voltage sources? I think it is better to use a whiteboard other than this PDF for better understanding purpose. I am sharing the whiteboard here. Yeah, I share the whiteboard. Are you able to see here? Let us talk about ideal voltage source. Ideal voltage source means, why these are known as ideal voltage source means, let me whiteboard కనిపిస్తుంది కదమ్మా. This is VS voltage source. And if I connect any load here, dotted means a load. If I connect a load across terminal AB, this is known as a load element. Load may be any fan like that, source may be a switchboard like that, you have to imagine. Now this is the ideal voltage source, and across this AB terminals, what is the voltage here? And we know the parallel voltages are same. So between the source and the load, there is no element. So ideal voltage source is the one which can maintain the voltage constant irrespective of the current. Suppose the switch is closed, current I is flowing in the circuit. The switch is closed, current I is flowing in the circuit. See here, if the switch is closed, current I is the current which is flowing in the circuit. But whatever the voltage which is available across the source, the same voltage will be available across the load. So I can say V equal to Vs. What is that? V equal to Vs. Why? Because there is no drop. Suppose there is a 100 volt source is there. The same 100 volt is available or applied across this load. ఈ లోడ్ దగ్గర అప్లై చేసే వోల్టేజ్ కూడా 100 ఉంటున్నాము. సో వాట్ ఐఎమ్ ట్రయింగ్ టు సే ఇస్ దట్ there is no drop. There is no drop in the source. In the source, the reason is that internal resistance. Internal means if generator is made up of some copper winding, all those things. Ideally, the generator resistance can be considered as a zero. As internal resistance is zero, so voltage drop across this one will be zero. So after talking about the practical element, practical voltage source, I will come to this internal resistance equal to zero, that point. And even though let me talk about the practical voltage source, then only you can conclude here. Let me talk about practical voltage. In practical voltage source, there is some internal resistance. Vs, this is Rs. Rs is some internal resistance. This is known as some practical voltage source. And this is your load, and this is voltage plus and across AB terminals. Now let us see here. So here we are observed that load voltage equal to same as source voltage. It is independent on the current which is flowing in the circuit once the switch is closed. Now, if you see this practical voltage source here, once the switch is closed, current is flowing. Current is flowing in this fashion. Okay, na? That current is I. So once the current is flowing, what happens across the resistor RS? చెప్తారా? కరెంట్ ఫ్లో అవుతుంటే రెసిస్టర్ ఆర్ఎస్ దగ్గర ఏమవుతుందమ్మా? అకార్డింగ్ టు ఓమ్స్ లా, V equal to RS into I. Some voltage drop will be there. Let us say that is V1. V1 is the voltage drop. So the polarities are plus and minus. Some voltage drop will be there across the resistor. Now if I apply a KVL equation in this, circuit. So KVL chapandamma, how many voltages are there? One source voltage, one load voltage, and one voltage drop across the resistor. So can anybody tell me KVL equation for this given circuit? Please respond. Please tell me the KVL equation for the circuit. Anyone from the class? 164? మా వినిపిస్తుందా నేను చెప్తుంది? హలో, KVL ఈక్వేషన్ చెప్పండి. ఇక్కడ Vs ఉంటుంది, V1 ఉంది, V1. Try to tell me the KVL equation for this given circuit. Current is assumed in clockwise direction. KVL equation చెప్పండి అమ్మా, సింపుల్ కదా.
Minus Vs plus V1.
Plus V1. Next?
Plus V.
Plus V equal to
0.
Very good. So that is the KVL equation. Let us substitute V1 value. What is the V1 here? V1 అంటే ఇక్కడ I into Rs minus Vs plus I into Rs plus V equal to 0. So from this equation, what can I write here? Voltage V equal to Vs minus I into Rs. Observe this equation. In ideal case, the terminal voltage is same as the source voltage. బట్ ఇక్కడ ప్రాక్టికల్ కేసులో అలానే అవుతుందా? అవ్వట్లేదు. ఎందుకంటే V equal to Vs minus I into Rs. The load voltage, this voltage V is known as a load voltage. Load voltage is dependent on which one? Current. అర్థమవుతుందా? ఈ కరెంట్ ఇంక్రీజ్ అవుతుంటే ఈ డ్రాప్ ఏమవుతుందన్న? ఈ డ్రాప్ కూడా ఇంక్రీజ్ అవుతుంది. If this drop is increases, I into Rs drop is increases across the internal resistance Rs, what happens to this terminal voltage? Terminal voltage తగ్గుతుందా పెరుగుతుందా? సపోజ్ Vs ఒక 200 అనుకోండి, I అనేది ఒక 2 ఆంపియర్ కరెంట్ అనుకోండి, Rs అంటే ఒక 1 ఆంపియర్ రెసిస్టెన్స్ అనుకోండి. 200 minus 2 198 అంటే వోల్టేజ్ సోర్స్ అంటే టెర్మినల్ వోల్టేజ్ ఏమవుతుంది? ఇక్కడ 200 వోల్ట్స్ ఉంటే టెర్మినల్ వోల్టేజ్ వచ్చేసరికి ఎంత వస్తుందమ్మా? ప్లీజ్ రెస్పాండ్ అవ్వండి. 198 వోల్ట్స్ వస్తుంది. దట్ మీన్స్ దేర్ ఈస్ ఏ 2 volts డ్రాప్. ఈ రెసిస్టెన్స్ దగ్గర, ఇంటర్నల్ రెసిస్టెన్స్ దగ్గర 2 volts డ్రాప్ ఉంది. సో ప్రాక్టికల్లీ it will be there, the drop will be there. Those are known as a practical voltage sources. But if you come to the ideally what happens to that drop? Ikkada drop ఏమైందమ్మా? If you come to the ideal one, drop ఏమైంది ఇక్కడ? What happens to the drop? The drop will be 0. Why? Because the internal resistance ఎంత అయితే drop 0 అవుతుంది? ఎనీవే కరెంట్ ఈజ్ నాట్ ఈక్వల్ టు 0, ఎందుకంటే కరెంట్ ఎలా ఫ్లో అవుతుంది? ఈ ఈక్వేషన్ చూడండి, V equal to Vs అవుతుంది కదా. అంటే దేర్ ఆర్ 2 టర్మ్స్ హియర్, వన్ ఈజ్ కరెంట్ అండ్ అనదర్ వన్ ఈజ్ ద రెసిస్టెన్స్. ఎనీవే కరెంట్ ఈజ్ నాట్ ఈక్వల్ టు 0. వాట్ ఈస్ ద అదర్ టర్మ్ షుడ్ బి ఈక్వల్ టు 0? టు మేక్ V equal to Vs in ideal case, resistance Rs should be 0. That is the meaning of ideal voltage source. For ideal voltage source, listen carefully. For ideal voltage sources, this is known as internal resistance. Internal resistance. For ideal voltage source, internal resistance R is equal to 0. ఈ పాయింట్ గుర్తుపెట్టుకున్నాం. థీరమ్స్ మనం డిస్కస్ చేసేటప్పుడు ఇది యూజ్ చేస్తాం. For ideal voltage sources, for ideal voltage sources, the internal resistance should be equal to 0. But practically there is some resistance. Okay. So that is the difference between ideal and practical voltage sources. And if you draw the graph between, if I want to draw the graph between current and voltage, నేను ఇక్కడే డ్రా చేస్తున్నాను. కరెంట్, voltage, this V and this I, if you draw the, then what will be the Vs? Vs will be constant. ఇలా కాన్స్టెంట్ గా ఉంటుంది. Because this terminal voltage is independent on the current. But if I draw a graph for this practical source కూడా అలానే ఉంటుందా గ్రాఫ్? Vs ఎలా ఉంటుందమ్మా? కరెంట్ ఈజ్ ఇంక్రీజ్ అవుతుంటే Vs ఏమవుతుంది? Vs is going to be what? Decrease. Because there is a current term in the equation. Ideal ganemo ila untundi voltage. This dotted line is for ideal and this thicker line for practical situation. Are you getting me or not? So that is the difference between ideal voltage source and practical voltage sources. Now let us talk about ideal current source and ideal current source and practical current source. Very, very important. What is the ideal current source? So this is the current source, IS, which is represented by IS, I subscript S, IS. So these are the terminals A and B. Across A and B, you have to connect a load here. Load here, and this is a load, load, and terminal C here, and this current is known as a load current I. Which current? That current is called load current I. So in this ideal current source, whatever the current which is present at the source value, suppose 10 amperes current in one, same 10 amperes current can reach to the load. The load koche current kuda 10 ampere ఉంటుంది. There is no division is taking place in this one. I will tell why it will happen later. I will tell after discussing about the practical current sources. And suppose if you take a practical current sources, there is an IS. For practical current sources, there is a resistance parallel to the internal resistance, parallel to the current source. Okay, na? Ikkada load ఉంటుంది. Load will be there. This is V plus and minus, and this is the current I. Now see here. Suppose if 10 amperes current is here, can you get the same 10 amperes current up to this point? Can anybody guess? Do you get the same 10 ampere current to the load in the practical situation? ఇక్కడ 10 amperes ఇచ్చారు, ఇక్కడ 10 amperes వస్తుంది, ఓన్లీ ఇక్కడ సిరీస్ కాబట్టి. Do you get the same 10 amperes current to the load here?
No, sir.
No. Because some portion of the current will flow through the which resistance amma? RS నుంచి కొంత కరెంట్,
Resistance.
RS నుంచి కొంత కరెంట్ ఫ్లో అవుతుంది. సో రిమైనింగ్ కరెంట్ విల్ ఫ్లో త్రూ ది, సపోజ్ ఫర్ ఎగ్జాంపుల్ ఇక్కడ 1 ఆంపియర్ ఫ్లో అయింది అనుకోండి, యూ డోంట్ నో దిస్ వాల్యూ బేస్డ్ ఆన్ దిస్, ఇక్కడ 9 ఆంపియర్ కరెంట్ ఫ్లో అవుతుంది. అంటే 1 ఆంపియర్ కరెంట్ ఈజ్ వర్టికల్ డివైడ్ ఇన్ ఏ పర్టికులర్ రెసిస్టర్. సో దిస్ ఈజ్ నోన్ యాజ్ ఎ ప్రాక్టికల్ కరెంట్ సోర్స్. ఇదంతా ఉంది చూసారా, ఇదంతా ప్రాక్టికల్ కరెంట్ సోర్స్ అంటారు. The current source in parallel with the resistor is known as a practical current source. But practical voltage source and voltage source in series అన్నమాట. అక్కడేమో voltage source series లో ఉంటుంది, ఇక్కడ current source కేమో parallel గా ఉంటుంది resistance. That is the difference between practical and ideal current sources. Now see here. So in these cases, yeah, let us say this is current I1 అనుకోండి, ఇదేమో I, ఇక్కడేమో 10 ఆంపియర్ కరెంట్ IS అనుకోండి. I write the KCL here by KCL, by using the KCL. I hope you are understanding. By using the KCL at this node. KCL చెప్తారు ఈ నోడ్ దగ్గర, ఈ కరెంట్ ఏమో I1 అనుకోండి, ఈ కరెంట్ ఏమో IE, అండ్ ఇదేమో IS అనుకోండి. సో ఎంటరింగ్ కరెంట్ కదా, యాజ్ ఈజ్ ఎంటరింగ్ కరెంట్ ప్లస్ IS, and this I1 is leaving current minus I1, and this I is also leaving current minus I equal to 0. But what is this I1? So this voltage is parallel to this one. So I can say the voltage across this one is V and RS is there. So V by, according to the Ohm's law, what is the I1 here? V by RS. Substitute V by RS here. IS minus V by RS minus I equal to 0. So from this equation, what is the I value? IS minus V by RS. The final equation. And this load current is depending upon which one? Voltage and రెసిస్టర్ RS. ఓకేనా? ఈ ఐడియల్ కేసులో ఇక్కడ ఏంటి, I ఈక్వల్ టు దిస్ లోడ్ కరెంట్ I ఈక్వల్ టు IS అవుతుంది. విచ్ టర్మ్ ఈజ్ ఆబ్సెంట్? V by RS ఈజ్ ఆబ్సెంట్. V by RS is absent. V by RS is absent means already there is a voltage V, kada? Voltage V undi, but RS voltage VS 0 avడానికి ఛాన్స్ లేదు. RS maybe it may be infinity or 0 as it is connected in parallel. Resistance అనేది parallel కనెక్ట్ అవ్వాలి కాబట్టి ఇక్కడ ఎంత వాల్యూ, దట్ మీన్స్ ఇక్కడ 10 ampere current, we are getting the 10 ampere current means how much current is flowing through this parallel branch? ఏదైతే 10 ఉందో ఇక్కడ 10 వస్తుంది కదా, అంటే ఇక్కడ పోయే కరెంట్ ఎంత ఉందమ్మా, ఎంత అవ్వాలి, 0 అవుతుంది. సో ఇఫ్ యూ వాంట్ మేక్ దిస్ I ఈక్వల్ టు 0, వాట్ మే బి ది R వాల్యూ, RS వాల్యూ ఎంత అవ్వాలి, ఇది ఈ రెసిస్టెన్స్ 0 అవ్వాలంటే ఎంత అవ్వాలి, V by infinity. V by infinity ఎంత, something by infinity 0. So what I am trying to say is that the ఇక్కడ internal resistance ఉందనుకోండి, that internal resistance value is infinity. ఎంత ఉంటుందమ్మా, ఇన్ఫినిటీ రెసిస్టెన్స్ ఉండటం వల్ల, యాజ్ దేర్ ఇస్ ఏ ఇన్ఫినిటీ వాల్యూ ఆఫ్ ది రెసిస్టెన్స్, కరెంట్ కెనాట్ ఫ్లో. ఎందుకంటే హై అమౌంట్ ఆఫ్ ది అపోజిషన్ ఉంటే కరెంట్ ఫ్లో అవుతుందా, అవ్వదు. అందుకని ఇక్కడ ఫ్లో అయ్యే కరెంట్ 0 అయిపోతుంది. టోటల్ కరెంట్ ఈస్ ఫ్లోయింగ్ త్రూ ది లోడ్. దట్ ఈస్ ద లాజిక్ ఇన్ ఐడియల్ కరెంట్ సోర్స్. So finally what I am trying to say is that this is RS is known as a internal resistance. Internal resistance of ideal current source. R is equal to how much? Please respond. Internal resistance of ideal current source is equal to infinite. So that as it is resistance is infinite, the load current is same as the source current. But it is some finite value, 1 ohm or 2 ohm. So some portion of the current is flowing through this practical current source of internal resistance. Remaining current will reach to this one. This is the difference between ideal current source and practical current source. Anybody have any doubts in this? అర్థమవుతుందా లేదా, మీరు రెస్పాండ్ అవ్వండి. మీకు రెస్పాండ్ అవుతుంది నాకు తెలుస్తుంది. హలో
Yes, sir, understood.
దినేష్ 177 19177 దినేష్. Dinesh, if you won't respond, I will give option for today class. Gopi Chand 166. Gopi Chand, Dinesh. Ashmita Reddy 176. 176. Ramya 2112.
Yes, sir.
Now, what is the value of? Are you able to follow, Amma?
Yes, sir.
What is the value of internal resistance for ideal voltage source? Ideal voltage source ki internal resistance ఎంత ఉంటుంది?
Infinite, sir.
వోల్టేజ్ సోర్స్ గురించి అడుగుతున్నాను. వోల్టేజ్ సోర్స్ ఎంత ఉంటుంది? వోల్టేజ్ సోర్స్ కి 0 ఉంటుంది. కరెంట్ సోర్స్ కి
ఇన్ఫినిటీ ఉంటుంది.
గుర్తుపెట్టుకోండి. దీస్ పాయింట్స్ we will use later while discussing about the theorems. Maheshwari, are you there, Amma? 164. 164. Ashok Kumar 20114. Ashok Kumar. I'm noting those numbers. If you won't respond, I won't give the attendance. 166. 177. Ashok Kumar 20114. 148. Dhanasri. 148. దీక్షిత నా వాయిస్ వినిపిస్తుందా మీకు?
Yes, sir. Viనిpiస్తుంది.
మరి వీళ్ళకి ఎందుకు వినిపించట్లేదు? So don't behave like this. You may be the loser అమ్మ. రేపు ఇవన్నీ ఎవరు చెప్తారో ఎలా నేర్చుకుంటారు? Don't do like this. From the next class onwards, I will strictly follow the rules. Once you join the class, compulsory you should respond. Otherwise, I won't give the attendance. I will talk with your HOD madam and who is your class in charge, Dikshita?
Giri Prasad.
Giri sir, kada?
Yeah,
I will talk with Giri sir and I will talk with your HOD also. This is not good. From my point of view, I may finish the syllabus, but you are the learners. On 48 good option. So this is the difference between ideal voltage source and ideal voltage source and practical voltage source, ideal current source and practical current sources. So all these things are explained in the notes very well. Now I will share the notes. See here. Yeah. Each and everything will be there in the notes. This one. This terminal voltage is independent on the current. So voltage will be constant for the ideal voltage source. But for practical sources, some drop will be there. That drop is depending upon KVL మీద ఇంతకుముందు అంతా రాశాను కదా, ఇదంతా ఉంటుంది. ప్రాక్టికల్ వోల్టేజ్ సోర్స్కి ఇలా డ్రాప్ వస్తుంది. అండ్ ఇక్కడ నోటేషన్స్ కొంచెం డిఫరెంట్గా ఉంటాయమ్మా. మనం ఫాలో అయిన నోటేషన్స్ వేరు, ఇక్కడ కేవీఎల్ రాసిన నోటేషన్స్ బోత్ ఆర్ సేమ్. ఇక్కడ కరెంట్ ఎంట్రింగ్ అయినప్పుడు మనం మైనస్ తీసుకుంటాం, మైనస్ విఎస్, ఇక్కడ ప్లస్ I into RS, ఇక్కడ ప్లస్ V వస్తుంది, విచ్ ఈజ్ ఈక్వల్ టు 0. ఈ ఈక్వేషన్ మనం రీరైట్ చేస్తే ఏమొస్తుంది చెప్పండి? V ఈక్వల్ టు VS మైనస్ I into, సేమ్ ఈక్వేషన్ వస్తుంది. The notations are different what we are followed earlier. The ideal current source. And this is practical current source. ఇక్కడ కూడా నోటేషన్స్ డిఫరెంట్గా ఉన్నాయి. ఎంటరింగ్ కరెంట్ ఏమో మైనస్గా తీసుకున్నారు, లివింగ్ కరెంట్స్ ఏమో పాజిటివ్గా తీసుకున్నారు. యూ కెన్ ఫాలో ఎనీ వన్, బట్ యూ హ్యావ్ టు స్టిక్ టు వన్ పర్టికులర్ రూల్. సో మనం తీసుకున్న కరెంట్స్ ఏంటి? ఎంటరింగ్ కరెంట్ IS పాజిటివ్, లివింగ్ కరెంట్ ఈస్ minus V by RS, and another leaving current is minus I. Finally, I ఏమవుతుంది, which is equal to 0. This I equal to IS minus V by RS. Both are same. Both the equations are same. Okay, don't confuse at that position. Yeah, this is about the independent sources. Other one is dependent sources, or these are known as control sources. Am I audible, Amma? Please respond.
Yes. Sir,
Now, independent sources are represented a circle inside a circle, plus and minus. The voltage source. Current source inside a circle, arrow. The current source. The independent sources. Independent sources are represented like this. But if you come to the dependent sources, and these are represented in different way. So a rhombus symbol, this is a rhombus symbol. Inside a rhombus symbol, plus and minus. Plus and minus means, can you guess what is the, is it a current source or voltage source? Plus and minus అంటే ఏంటమ్మా, current source or voltage source first of all?
Voltage source.
Yeah, voltage source kada, ఇది voltage source. Dependent means this value of voltage, the value of voltage is depending on other element. Other element means some K1 value. K1 is mentioned somewhere. That is the meaning of, I will take an example and I will tell what is the dependent sources, how it will depend on all those things. I will explain very clearly. And there are 4 types. One is voltage controlled voltage source and voltage controlled current source. Current controlled voltage source and current controlled current source. Okay. So let me give a practical example how it is depending on in a particular circuit. Let me take an example here. I'm sharing the whiteboard here. We're talking about the dependent sources or controlled sources. So let me finish this topic. Dependent sources. Independent sources we already discussed. Now let us come to the dependent sources. Now tell me, this is which type of the source? The A source amount. Is it dependent or independent? Please respond.
Independent.
Yeah, the independent source. Now there is a resistor and V1 plus minus. This is, let us say, 5 ohms something. Rhombus symbol, inside a rhombus symbol, arrow direction. Arrow direction ante idi current source or voltage source? Cheppandi first of all.
Current.
Arrow ante enti?
Current
source kada. So this will act as a current source. దీన్ని current source అంటారు. Current source అంటే CS అంటారు. Current source CS. And this current source is depending upon some V1 into or 5 into V1 అనుకోండి. 2 into V1. So wait for 1 minute. Please wait for 1 minute. See here. See here. This is 2 into V1. Am I audible, Amma? Please respond. వినిపిస్తుంది కదా?
sir.
Yeah, let me finish this. 2 into V1. V1 is mentioned across this resistor V1. So after calculating the V1, if you substitute this V1 value here, you will get this final value. But if you observe this 20 volts, it doesn't depend on any 20 volts. This doesn't depend on the another element which is present in the circuit. Okay, na? But this is depending upon voltage or current. V1 kada. So V1 may depend on. So can I say this is voltage dependent or voltage controlled? Voltage dependent or controlled? Anyone you can say. Voltage controlled. Which source? Current source. Adhamanda? This is what? 2 into V1 is there. That means the value of this source is depending upon the which one? Voltage. So it is known as voltage controlled current source. Okay, na? So I will take another example here. Plus and minus. Can you tell me what is the name of the source here? This is which source, Amma? Inside a rhombus symbol, plus and minus are there. Plus and minus and which source it is acting? It is acting as a hello.
Voltage, sir.
That is voltage source and voltage source VS and voltage source and VS. And this voltage source value is depending upon which value? Current value. I. That current is flowing through this 10 ohm resistor. I. That means the value of this voltage source is depending upon the current I1. Okay, na? So what I can say the source here? Current controlled. I think you are getting current controlled which source? Voltage source, because this value is depending upon the current. So this is about the what? Current controlled voltage source. So let me take another circuit here. This is minus the 10 volt source resistor, and this is another resistor, and now tell me what is the name of the source? Please respond.
Current control current source, sir.
Very good. Current controlled CC and current control. Current controlled which source? Current source. So this is 1 and this is 2, this is 3. Okay, na? Now What is the name of the source? The value of this, it is a voltage source, it is depending upon V1. Where V1 is mentioned? V1 is mentioned here. So that means the value of this source is depending upon the other element which is present in the circuit. So it is known as voltage controlled voltage source. So how many dependent sources are there or controlled sources are there? How many dependent sources are there? 4 dependent sources. Those are voltage controlled current source, current controlled voltage source, current controlled current source. Another one is voltage controlled voltage source. 4 sources. So these values of these sources are depending on the value which is depending upon the other element which is present in the circuit. That is the difference between. But if you see the independent sources, this value doesn't depend. It is 20 means 20 volts only. The value is double, doesn't depend on anywhere. Okay. So these are the dependent sources and independent sources. Representation is different. It is a circle and it is a rhombus symbol. Dependent sources are represented with the rhombus symbol. That is the difference between voltage dependent sources and independent sources. So I stop here. So ఇక్కడ మీకు నోట్బుక్లో ఇవన్నీ అవేనమ్మా. సో దట్ ఈస్ ద మీనింగ్ ఆఫ్ ఇక్కడ. So now we can understand very clearly here. Voltage controlled voltage source. This is voltage controlled voltage source. Voltage controlled current source, because this value is depending upon the voltage, and this voltage is mentioned in the circuit somewhere. And this is current controlled voltage. This is voltage source, but this value is depending upon the current. So current controlled voltage source. And this is a current source, and this value is also depending upon the current. So current controlled current source. Current controlled. Full current controlled current source. Okay, so these are about the sources, type of the source and types of the elements. And one more information is that with respect to controlled variables, the dependent sources are said to be linear, active, and bilateral timing variable. The presence of these elements makes the network is linear, active, and bilateral. And the important point is this one. These control sources are dependent sources, both are here. These control sources are said to be the sources, that is active elements in the circuit. At least one independent sources should be there. Then only these control sources are variable or non-zero. That means, what is the point to says that if you want to say this is a particular source 5 into I1, compulsory there must be a one independent sources undali. Then only these sources are valid. Otherwise the sources may be